Hi, I'm Corinne.
I'm Maci.
I'm Lindsay.
Welcome to a Math Extra Credit.
Today, guys, I'm recording. Be connecting
We are going to be.
this corner of the table to this flower pot, to this big flower pot, back to this corner of the table. Here is the overview. As you can see, the corner of the table, the flower pot, and the other flower pot. So that is our triangle today.
Break my flower pot.
So from the flower pot to this corner, we have it at about 14 feet and 7 inches. Whoa!
You're a little off.
And from the corner to this flower pot, we have about 11 feet and 9 inches.
Excuse you. Oh my god, that noise was the worst thing I've ever experienced. But I didn't know.
From this flower pot to this flower pot, we have about 8 feet and 2 inches.
Okay, so this is our triangle drawn out on paper. Then we converted everything from feet to inches to make calculations easier. Now we're using the law of cosines to find the biggest angle first. First, we plugged in all our numbers and we squared them and did some multiplication. Then we simplified further, added
These two values.
9,604 plus 19,881. Once we add those two together, we subtract that from the left side. And then we have to divide by what we have left, which is 27,636. And then we divide by that. We did the inverse cosine to get the angle of A, which equals 87.64 degrees. Okay. Now that we have the angle measurement for A, we use the law of sines to find the angle for B. So this is our formula, our equation for law of sines. So we plug in for A, 87.64 degrees. So we do that and we put that over top of the corresponding side. So we find angle A, and then you correspond that with the side A, which is 175 inches. So we put that down here. And then B is what we're looking for, so we plug in B. And then the side corresponding with that would be 98 inches. So we put that at the bottom. And now what we're going to do next is cross multiply and then do the inverse sign to find the angle measurement for B. Okay, so after doing all of that, like I said previously, we simplified and then we did the inverse sine of 0.5595, and that gives us 34.2 degrees, which is our angle measurement for B.
Nice. Hey. Okay. So now that we have both angle measures for for A and B, we can figure out C easily by just adding A and B and figuring out what that is, and then subtracting that from 180, and we end up with 58.34 for angle C. So finally, to get our area, we're using this equation, A equals 1/2 AB sine C. So we plugged in our values for A and B, which is 175 inches and 98 inches, and we also plugged in the sine for C, which is 58.34 degrees. And then I simplified by multiplying these two values and then dividing by 2. And then I simplified sine of 58.34. And finally, we get our area of 7,298.85 inches squared.
So for part 2, we're going to find both the other side, B, as well as angles B and C. So first, we started by sketching the triangle. So A is equal to 22, C is equal to 25, and the angle of A is equal to 55. So starting part 2, we're going to use the law of sines. So law of sines here, we're using sine of A over A equals sine of C over C. So we started by plugging in the sine of A, which is 55, over 22, because that's the side length, and it is equal to the sine of C over the side length of C, which is 25.
Why did you give yourself like a shot of iced tea?
Oh, I thought it was way more than that.
You literally poured yourself.
No!
Okay. So we're going to start by doing the sine of 55 and cross multiplying it. So you do sine of 55 times by 25 is equal to the sine of C times by 22. Okay, anyway.
I need food.
A new adventure awaits you this weekend.
Yay! Clean conscience is a good pillow.
The sine of 55 times by 25 is equal to 20.48, which is going to be equal to the sine of c times by 22. So if you divide both sides by 22, it's going to equal 0.931 is equal to the sine of c. And then you're going to do the inverse sine of 0.931 to equal c. So you find that your angle measurement is 68.57. So now we're going to test if there's two triangles. So first we're going to start off by using this method. So the angle A was given to us, so A equals 55, and then you can put 55 on the side as well. And then in our last part, we found that B, oh no, it's C. That C was equal to 68.6. Then you're supposed to find the supplementary angle, which is 111.43. We found this by subtracting 68.6 from 180. Next, we add it together, both 55 and 111.43 to get 166. Because this number is under 180, that means that there's a second triangle, and the last angle of the second triangle is 13.57.
Hey!
No! Triangle 2 are 55, 13.57, and 111.43. The angles for triangle 1 are 55, 56.43, and 68.57. We found the angle B by adding together both angles A and C and then subtracting them by 180. So this is what the true triangles would end up looking like. So first we're going to use law of sines to find...
Look at this.
Stop! Oh! Find the last side for the triangle. So we're going to do the sine of angle B over B equals the sine of angle C over C. We're going to do the sine of 13.57 over B equals sine of 111.43 over 25. After you cross multiply these two, you're going to get the 5.87 equals sine 111.43 times B. Then you find the side B equals 6.30 after you divide this by sine 111.43. For the first triangle, we're going to do the same exact process. So do sine of B over B equals sine C over C. Okay, so then we're going to plug in the values to do sine of 56.43 over B is equal to sine of 68.57 over 25. So once you cross multiply these numbers, you're going to get that 20.83 is equal to the sine of 68.57 times by B. And then once you divide both sides by the sine of 68.57, you're going to get that the side length B is equal to 22.38. Finally, we found out all of the... Okay. So we found out all of the missing parts of the triangles. So for triangle 1, angle A was equal to 55, angle B was 56.43, angle C was 68.57, and then side length A was 22, side length B was 22.38, and side length C was 25. For triangle 2, angle A was 55, angle B was 13.57, angle C was 111.43, side length A was 22, B was 6.30, and C was 25. Okay, so to find the area of the two triangles, you're going to use the equation area equals half AB sine C. So for triangle 1, the area is equal to half 22 times 25, and then the sine of 68.57 to get 255.99 units squared, and then the same thing is done for triangle 2. So area equals half 22 times 25 times sine of 111.43 to get 255.99 units squared.
Thank you.
Thank you for
watching.
That's our video.
Watching.
Thank you.